Where I'm at. Is this recording? Did I hit record or I just hit Yeah, okay. So, you understand the question, but that how to use differentials, well, that is another story, yeah? So, if you were to say one big idea from Friday, it's this. Change in y can be approximated by dy, and dy is a rate of change, or a ratio of how y changes with x, times an amount of change in x. All right? Now, big ideas of calculus. This is a little bit of change. Understood? Get that in your head first. Also, if you really understand calculus, then you'll also know that, hey, when I then do an integral, and you say that's a little bit of change, then isn't this the sum, that's what that stands for, that's sum of lots of little bits of change, giving you a total amount of change, and isn't that the fundamental theorem of calculus? Summing lots of little changes gives you change. You with me? Yes. Cool. And if you're going to sum all calculus in one word, that's it, change. It gives you change. Now then, the question then is, all right, well, I understand the big idea, I'm with you. How do we adapt then to this situation? Well, in this case, think of a starting point, and then how does change, or what does change have to do with it? What's the starting point? Cube root of 67 is close to a starting point of 64. So this cube root of 67 is like the cube root of 64 plus some change in going from 64 to 67, yeah? And so it's going to be like 4 plus some change, 4 and change, right? Now the differential idea. Delta y, or that true change, can be approximated by dy, and dy is the rate of change at the starting point times an amount of change in x. Now in this case, the function, it's hard to take f prime if you don't know what the function is. What's the function? Cube root of x, or x to the 1/3. So what is f prime? 1/3 x to the negative 2/3. And at what point are we going to find the rate of change? At 4 or 64? At 64. And then dx, or delta x. How much are we going to change x by? 3. Is that a positive 3 or negative 3? Positive 3, because we went from 64 up to 67. That said, then, this is 1/3 times the cube root of 64 squared times 3. Those 3's go away, I suppose. And so what is the cube root of 64 squared? 16. And so that is 1/16. So to answer the final question then, I could estimate the cube root of 67 as 4 plus some change, or an estimate of 4 and 1/16. You with me? Yes. How would you calculate delta y if you had a calculator? Delta y, not dy. Delta y, what is it? Okay, this is an approximation of the change. Or this, sorry, that's an approximation of the change. Delta y represents the true change. So, what is it? Oh, wait. The true difference in the outcomes. What would you calculate? Just say it out loud so we can move on with our lives. Please, I beg you. I can wait as long as, just, I didn't say calculate, just tell me what to calculate. Cube root of 67 minus cube root of 64 or 4. That's the true change. That's the actual difference between the two outcomes. We estimated that change or that difference with calculus to avoid that, but they should be in the same ballpark. All right. Let's then go to the backside. That's a different type of differential problem here. I'm going to let you do this one. I feel like it's a little too much me now. So feel free to use your notes if you like, but this is another differential calculus idea of using or relating change to the original thing. While you do that, I'm going to hand back this here bad boy. How's that going? All right. Free to use those notes. That's why you take them. Start putting those up. Out, we're going to go over some of the math behind it. Maybe you'll write yourself one or two. I know one problems that were confusing. Baseball this week, right? I asked her. Oh, gotcha. All right. Okay, how are we doing? Do you need to point in the right direction? Yes. Okay, so start off with the big idea. Y equals f prime dx, but in this case, you're talking a little something different. You're talking, what is the function here, and estimating the theta. Let's talk about the picture here. It's like this, yeah? The person is standing 50 feet from the release point. Here's the balloon, and it's rising. This is 50 foot. This is the person doing the seeing. Technically, this is not a right triangle, which makes the problem considerably harder if it's not a right triangle. So let's just assume the guy's on the ground doing the seeing, because then we're dealing with right triangles. Very cool. This is also a variable of interest, and this is varying. So the question then is relative error in estimating the height of the balloon. Actually, maybe I'll call this H. Are you down with that? All right. Now, relative error is to first find the error or estimate the error in calculating the height. If your angle is off, then your height calculation would be off as a consequence. That error, or how much your height could be off by or differ by, that's the differential. That's dH. We're trying to estimate delta H, or what the height could be off by with dH. So that's the first part. We'll do that relative, or that differential part, to estimate dH. But then often, after that, you say, all right, well, great. It could be off by 0.1 radians, or 0.1 feet. Then you say, well, is that a lot? Well, that's relative. That's why the relative part of it, you relate that to what you're finding. And that tells you then, as relative to or related to what we're measuring, it's a tenth of what I measured, or 100th, or whatever kind of thing. Are you with me? Okay, so DH. DH then would be H prime times some change in what? D theta. Yeah, beautiful. All right. Now then, let's get an equation, shall we? How would you relate these two variables? Sine, cosine, tangent, Pythagorean theorem, similar triangles. I can imagine lots of different possibilities with the triangle. Tangent, beautiful. Tangent of theta. Tangent of theta is h over 50. And if we were to clean this up and solve it for h is 50 tangent theta. Do you agree? Yes. All right, cool. And when I find h prime, what is h prime? 50 secant squared theta at a theta of 5 over 6. And what's the d theta? Plus or minus 0.1 radians. Okay? Now, gosh, this is a little kooky here. 1 over 50 on top. And cosine, secant squared is the same as cosine squared in the denominator, right? What is cosine of pi over 6? Is it 1/2 or root 3 over 2? 1/2. Root 3 over 2 times plus or minus 0.1. Are we cool? So that's something like 50 over 3/4 times 0.1. That's 50 times 4/3 times plus or minus 0.1. 200 thirds is what, about 66.6 repeating? Sweet. And therefore, times 0.01, 6.6 repeating, plus or minus. What are the units on that? Is that radians or feet? That's feet. That's a height calculation. Okay? By being off about this much of a radian, the height could therefore be off a little bit of 6 or 7-ish feet. So far, so good. All right. Now, to find the relative error, I take that possible, it's the absolute value, so don't sweat the plus or minus anymore. That relative error of possibly being off as much as 6.6 feet related to what the height is at that instant. What about the height at that instant? The height when the angle is pi over 6 is 50 tangent of pi over 6. What's tangent of pi over 6? Is it root 3 or root 3 over 3? Root 3 over 3, that's the idea of the smaller side, opposite over root 3. So it's root 3 over 3 times 50. So 50 root 3 over 3 is the height. That would be a decimal if you were to slap that in. That's the relative error. That makes sense? You might then say, make it a percent, say it's 3% error or something like that. That's, somebody throw that in your calculator and let's run it in for the touchdown. I'm going to call this actually 200. This is 20 thirds. This is 20 thirds times 50 root 3. This is 2 over 5 root 3. 2/9-ish. What do you got there? Is it decimal? Some? Anybody? Some decimal answer? 25? 23-ish? Okay. So the relative error is a decimal, the percent error would be a percent, so whatever it is, 0.23, whatever that is. You follow me? Okay, would you do 23 on your own, and then we'll move along. Our warm-up period will be complete. If you're good at mental math, you might do this mentally. If you're not so good, at mental math, you might make a huge chart. Maybe start by saying when x is 0 and y is 1, 2, or -2, -1, 0, 1, and 2. That's a lot of chart, you know, so if you can do it mentally, the more the better. Or maybe it would be better. Do you like the matrix? Would that be better? Maybe not. I would start by the easy stuff. When x is -1, what do you get? 0 slope. So when x is -1, 0, 0, oops, do this in color. 0, 0, 0, 0. And when y is 0, what do you get? What kind of slope when you have a 0 in the denominator? Vertical. So when y is 0, which is here, 0, 0, 0, 0. This point here, where you have 0 at the top and 0 at the bottom, that doesn't exist. Do not graph it. Okay, so this point at -1, 0, put nothing. Oh, fine. Thanks. And something like that. What do you think? Okay, in anyone reading across, your slope should gradually get steeper. So from negative to 0 to steeper and steeper positive. You with me? Okay. Would you look at that blue packet? Now here's the deal. Actually, and let's also look at the old schedule, as they say in English. So, this is, wow, that problem set that you're just starting, this is the, for seniors, that's the last stacks of problem set you'll ever do.
No way.
Really, it is. 100. Okay. I'm going to teach the lesson for that tomorrow, so you should be able to do all of the 100 except for anything that has a little 100 subscript. I'll teach that tomorrow and you'll be able to finish that. So your homework tonight should be to get most of that knocked out. Cool? Okay. All right. Now then, we have 2 orders of business then left. We have to practice those last lessons and test over all the most recent stuff. The most recent stuff is trapezoids in 95, absolute value inequalities, or absolute value integrals, and piecewise integrals in 96. 97 is volumes of cross sections. So similar semicircular cross sections, all that stuff. It seems like that's going pretty well, I gotta say. 98 is fundamental theorem of calculus, part 2, where you take the derivative of an integral. That students usually do it. And estimating logs by trapezoids. For example, if I said the log of 3, estimate it, you'd say that's equivalent to or can be approximated by the integral. From 1 to 3 under 1 over x, right? And then you can use trapezoids to estimate that. 99 is differentials, which is no picnic. 104 is slope fields. And 100 then I'll teach tomorrow. Yeah, you're going to have 2 days to practice on her before being tested on it. Welcome to college. All right. Now then, so tomorrow, the classes are not as shortened. They're only 45 minutes. They're only shortened by 5 minutes, rather. The study halls are not as long. So it's a Tuesday, Wednesday, Thursday weird schedule situation. Are you with me? Okay, so the study halls, rather than being 85 minutes or whatever they were, I can't remember. The study halls are 45 minutes. The periods are 45 minutes, with the exception of 6 hours. 6 hour kind of gets you after, it's 5 minutes less. But they're about 45-minute classes. You with me? Tomorrow I'll teach the lesson, and I'll start giving you practice on the recent stuff. You could say we're going to basically just practice for the test Tuesday after the lesson, Wednesday after the lesson, and your last test is Thursday. Again, the focus on that is 95 through 100 plus 104 and second derivative implicit.
Wait, did you say that's our last test?
That's your last, no, I misspoke. That's your last Saxony book lesson test. You with me? So next week you'll do a last part 3 of an AP practice test, and then you'll have your AP final. All right? That's where you take the second derivative of an implicit equation. Kind of the end of that slope field calculus, which I need to get you back at least. That's the idea for the week. Are you with me? Okay, good. That blue packet, some of those packets, the problems in the blue packet, you're going to see on the test on Thursday. I want to see if you learned from your mistakes. So, you might, if I were in your shoes, I would get out a colored pen and write yourself notes on anything that you either guessed on or you straight up missed. All right?
I lost it.
Just leave it back like 10 minutes ago. Hey, this one, the big idea was you needed to use identity 1/2 minus 1/2 cosine of 2x. And then most people knew that, but then they u sub or guess and check badly. This antiderivative, it's either straight up u sub, or for something this simple, I would suggest a little, maybe just guess and check. You can avoid u sub on really simple ones by just guess and check. All right? 16, I only had 4 people miss 16, so I feel like that was good. 17 was a bit of a humdinger. That said, I only had 5 people miss it, so it was really good. But the idea was it was washers. The setup was pi times the upper sine of x squared minus the lower 1/2 squared, and pi over 6 to 5 pi over 6. Then later, also using the sine squared is 1/2 minus 1/2. This is plus, darn it, I said minus, this is plus, yes?
Yeah.
Sorry about that. Using the sine squared is 1/2 minus 1/2 cosine of 2x identity. That to me is a really good question because it drew on several different skills. Integration skills, identity skills, and washers, obviously. So I like that question. Are we good there? Please if you have, follow-up questions, jump in, please, because like I said, you're going to see these again. 20, this was a L'Hopital twice question. If it's multiple choice, what I would consider quote-unquote good work could be abbreviated a little bit, like showing each part zero separately. I didn't grade for that. But if you're going to do this question well, then you would have had to have used L'Hopital twice. The answer was B. Okay? Number 21 was one of the harder questions. Even though it was calculator active, this was in the wrong place, but it was calculator okay. The key to this was making the verbal connection. Tangent lines parallel means the derivatives are equal, right? Now, one derivative was given, f prime is given. The other derivative you had to take was 3/2, and then you had to find intersection points in your calculator. Some people had all that work, they had the right idea, but then they circled 2 or something like that. I don't know if you just didn't graph the entire window, or I don't know what happened, but I had 7 people miss that, and a good chunk of those had the right idea. So you might check your calculator skills on that one. You good? Okay, moving on to page 2. A lot of people miss this one, 6 people. I feel like 0 people should miss this. When you do trapezoids of equal subdivisions, you will have to, on the test and on the AP test, and just in general in calculus, work with 2 types of trapezoid problems. If they're equal subdivisions, then it's the height over 2 factored out, and the f, 2f, 2f, pattern. H is delta x, and delta x is v minus a divided by n. So I feel like if you were choosing from anything besides C and D, you don't know what you're doing. C and D are the only possibilities. A, B, and D, or A, B, and E are out. You just better know. Nope. Okay? So make sure you understand that component. Are we cool? All right. This guy, only 2 people missed this. This went well. This last one on that page was only hard because the right answer wasn't there. But I did tell you to forget any of the answer choices. The correct answer, this was either calculator, or you could take the derivative by hand. Now, while I appreciate, if you took the derivative by hand, I appreciate your gung-ho-ness. In terms of time on a test, that would be a time eater to do the product rule and chain rule on that and do all that stuff when you could just put it in your calculator, right? So you would say the derivative of, and that's in the calculus submenu, of the function at the value of x equal 1, first derivative. So if you don't remember how to use your calculator derivative, that's definitely something you should review. You need to have that. Are we good? So the answer decimal-wise is about 5.889, I believe. If you did it by hand, it's 13e over 6. Okay? Okay, let's go to page 3. This average velocity, I'll say it once and I'll say it again. This is one of those things that I remember having trouble with. Average velocity is not always calculated the same way. If you're given position, then average velocity is the change in position over a time interval, yeah? But if you are given velocity, then you say, what is the average value of the velocity? And that's this. And with a little bit of thinking of what would the antiderivative of this be? Well, this would be x of v minus x away. They're the same. It just goes to whether you're given one or the other. Now, in this case, you're given velocity, so you should be working from the average value of velocity perspective. If you tried to integrate that by hand, you're on a fool's errand. That cannot be integrated by hand. You're wasting your time. You're never going to be, you can, all your life, you'll never get it. It doesn't have an integrated. It's a calculator problem, okay? Anytime you do a tangent line, you first make the tangent line and then you make your approximation. The tangent line requires a point, a slope, which uses the derivative at the point, and then you write point slope. After you do that, then you put 1.1 into your tangent line equation to get the estimate. Okay? 76, that surprises me. 79, 8 people missed 79. And that's a pity. I understand the overarching question is what is our tangent approach, but I can't know what our tangent approach is until I know what f approach is. So as x goes to 2, what's the limit or the y value approach? Does the y value approach 1 or 2? 1. Limit is approach. Approach. Okay? And so this is the arc tangent of 1, which is at what angle is tangent 1? That's pi over 4, whatever the one is that's probably that one. It's that one. Okay? So that I feel like was not something you should have missed. 80 on a no calculator problem would be a humdinger, but on a calculator problem, not too bad. Here's what I would have done, and I think it's quickest. Speed is decreasing. If it was a no calculator problem, I would have to find where do velocity and acceleration have different signs. And that's a bit of a pickle in some cases. But with a calculator, couldn't I just say find the speed and then look at the graph to find when it's decreasing? So if the position is s of t, then what's the velocity? Quickly, let's go. Derivative of that, 6t squared minus 54t plus 84. What's the speed, therefore? If that's the velocity, what's the speed? Absolute value of that, yay? So, I just graphed that in my calculator and found where speed was decreasing. And it was on those intervals, although you could have done it without a calculator. That's how I did it. Okay? Are we good? 81 is a classic AP calculus problem with low averages because it requires you to put two skills together. What is the position when its velocity is first equal to 0? Well, first thing you find is find when the velocity is 0. That's just by your calculator. If you graph the velocity function in your calculator, velocity is 0 at roughly 1.3795. Now we need to find the position at that time, given the velocity. How do I get from position to velocity? Derivative or antiderivative? Antiderivative or derivative, did you say? Antiderivative. Velocity is the derivative of position.
You said it backwards.
I did it? No, I think you did.
No.
What?
You said position to velocity.
Oh, how do I get from velocity to position?
Antiderivative.
Okay, you're saying it's my fault.
Yeah.
Okay. Tell me this. If I go from 0 to 1.3795 of v, this goes to something I said earlier. Does that give me the position at 1.3795?
No.
No, it's the, what is an antiderivative or identical representative? Change. It's the change. It's the change. It's not the position. It's the change. Okay? If I want to know what the position is, then I can't just slap an integral at it. That's the change. If the position is wanted, I have to take into account where it started and the change. And that is by far where most people made their mistake, which was frustrating. It was D. And then 82 was also a humdinger. 9 people missed that, roughly a third of the class. It's expected. This is hard. What does F prime negative imply about the table? It needs to decrease. And what does F double negative mean? The changes need to decrease. Now that said, this was still hard because of the negatives in there. This is going up. So wouldn't you agree that this is increasing? So that's out. This is increasing. So that's out. The first derivative rules out A and B. They're gone. They have no chance. And the rest are decreasing, so they're in. This is, what's the change here? 4? No, not 4. Negative 4. Negative 4, negative 3, negative 2. This change is negative 1, negative 3, negative 5. This change is negative 3, negative 3, negative 3. That right there says that guy's out. Which of those between C and D are the changes decreasing? Is this decreasing? No. Negative 3 is not less than negative 4. It's more than negative 4. Is negative 3 less than negative 1? Yes. Is negative 5 less than negative 3? Yes. These changes are decreasing. Okay? All right. This, for the most part, went pretty well. You were looking where F prime equals 0, how many times on the interval? And the answer was C. That's what I did anyway. I suppose you could have done it a different way. This one was, very few people missed that one, especially with the calculator. That's not too bad. And actually, if you threw that in your calculator straight up, did it do it okay?
No, it said
There's a yeah, there's discontinuity in there. That might have been the problem. If you looked at this visually, around 0, there's a bit of a switchy switch. Before 0, these work out to be negative 1. Negative 1 plus 3 is 2. It looks like this here. And then after 0, these are the same. And so that's 1 plus 3 or 4. So I just did this. I didn't pick up my calculator. I just did 2 rectangles. This region is 6. This region is 8. So it's 14. Okay. That was a hard one. 25 was also a humdinger. 14 people missed this. That makes it one of the 2 most missed questions. Understandably so. It was hard. The problem, obviously, is to find the change of C with respect to time. Well, that's great, but C isn't a function of time. C is a function of velocity, and velocity is a function of time. So you could do this one of 2 ways. If you're just the super magnificent calculus student that understands the chain rule on the deepest possible level, then that works, and that's awesome. But most students find it easiest to say, you know what, let me make C as a function of time, then take the derivative. Now, here's the key though. Velocity increases at a constant rate. That means dv dt is positive 6. Now, that would imply that v is 6t plus a constant if I integrate, right? Now they tell me at time 0 velocity is 15, so if I use that, velocity is 6t plus 15. Are we cool? Now if you then substitute that into c, so that c relates to time instead of velocity, then c is 35 minus 7 times the 4th root of 6t plus 15. Then you can take the calculator and c as a function of t at 8, and you're rocking and rolling. Most students that were successful did it that way. That makes a lot of sense to me. With me? That was a hard one. The answer was E. Okay. 86. By far the big idea was that when you do semicircles, that the volume is pi over 8 times the integral of the diameter squared. And it was all with respect to x for this problem. So if you didn't get that one, I would write it that way. That means then that the volume is pi over 8 times the natural log squared from 1 to 2. Okay? The answer is A. Only 5 people missed 87. The idea is 1 over f prime at f inverse. The hard part by far, that is finding f inverse at 6. That means this is 6. What is x? And what is x that makes 6? It was 1. So you should have been putting 1 into f prime, not 6. And then 88 was the most missed question. Out of roughly whatever 25 people that did this, 18 missed this one, which is very understandable because it was hard. Okay. Now, if they intersect at right angles, then that means their tangent slopes are perpendicular opposites, yeah? Right? Okay, so for example, I said if the derivative of this is 1 over x, then at the intersection point, at the point where they meet, their slopes have to be perpendicular. Some of these I just ruled out by knowing the graph. Natural log of x plus 2 is shifted up 2, right? This to me was not going to be perpendicular there, so I didn't even try that. I felt like this was a maybe. I didn't know for sure there. This I felt like I was a maybe. I wasn't sure. This was a maybe. I guess in retrospect, that didn't rule out many choices. After that, then, I said, what did I say? I said, where do they meet? And their intersection point. So, do you want to do their intersection points though? That kind of sucks. So let's go here. What's the derivative of this guy going to be? Y prime is negative x, yeah? All right. At the end of the day then, this is y prime equals negative 1 over x squared. This is what I decided. Y equals x. Y prime equals negative 1. Y prime equals 1. Which of those looks like negative reciprocals of each other? Tangent slope is opposite reciprocals, yes? Which of those looks like opposite reciprocals of each other? Those two? And so it is. Okay? All right. This had a mistake in it. I assume he meant from negative 2 to 8. I wasn't sure. But the only answers, even with that mistake, the only answers that could have made sense either way is 1 and 3. If you looked at it as, all right, I'm going to think it's 4, then I can't tell anything, and you could say none because you don't know jack anything about 4. If you said they must have meant 8, then the only ones that could be definite must are the average rate of change is 3/10 and the average value of change, which these are the same by the way, is 3/10. This could be, but the key word is must. And this would not, you just couldn't say. It doesn't have to be a must. And so that one at the end of the day, it was a bit of a gotcha. 90 was a great fundamental theorem of calculus part 2 question. They give you this crazy antiderivative of f function, but they ask about f. Well, shoot, if I want f, then that means I want to get rid of that antiderivative. What gets rid of an antiderivative? A derivative. If you took the derivative of both sides, then you get f is the derivative of that. If you just did that at pi over 4, then boom, you're on your way. So take the derivative of both sides. The thought process would be, I want f by itself. How do I get rid of the antiderivative? What's the opposite of the antiderivative? Derivative. All right. 91. This went pretty well. That was fine for the most part. Only 3 people missed that. And then 92 was also missed by quite a few, also understandably. I understand if you're a little confused, but if you didn't even make use of this, then I said you skipped it. You didn't try hard enough to me. Point of inflection right away tells you you're going to need f double. So if I didn't see you even try and get f double, I felt like you didn't give an effort. F double is 2k minus 1 over x squared. All right. Now after that, it's still a hard problem. There's a second condition, and that is on the x-axis. What does on the x-axis imply? If a curve is on the x-axis, then you know x is 0 or y is 0? Y is 0. So you use this fact in conjunction with this fact and substitution. And this side, the second derivative probably is going to be 0 if it's a point of inflection. So those two things together get you the answer. I used a little bit of substitution. K is 1 over 2x squared. From that, if I substitute that in there, then 0 is 1 over 2 minus log of x. That means log of x is 1 over 2, which means x is e to the half. That's great. I was freaking out because I didn't see that answer. But the question isn't what is x. The question is what is k. And so if k is 1 over 2 times x squared, then it's 1 over, that's not an answer. What is the answer? What's going on here? What did I do wrong? This should be positive, right? Gotcha. Thank you. Okay. So that should be negative in there, and so on. So it was actually a negative 1/2, and that's how it ended in the numerator. So let's see. Sorry, I was a little careless with the details, but it's C 1, 2, 5. You with me? And man, I was so happy with how this first free responded. I mean, the mean was a 9, the mode was a 9, the median was a 9, sorry. The median was a 9, the halfway score was 9, the mode was a 9, the mean wasn't a 9. Not everybody got 9, unfortunately, but for the most part, that went really well. I was really happy. That is a pretty good bet for one of the free responses on the test, and I was very happy there. Last but not least, 3. This is probably the best example of all calculus you could get.
Ready? Begin. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
I'm going to focus on mean.
Attention interactive musical school participants. Please stop by Mr. Jones for 7 hours after school for more information about a date change for our final visit. FBI Denver Community Testing. Spend a day with special agents looking into criminal and cyber investigations, gain experience with evidence collection, and much more. Must be incoming sophomore, junior, or senior. The academy is June 12th. The deadline has been extended to April 22nd, and counseling has the details.
Registration is now open for the bioengineering opportunity. University of Colorado Denver and Chief Medical Campus for the summer of 2019. The 4-day interactive classroom of biology and engineering. Two sessions are available this summer. Stop by counseling if interested.
Registration is open for Colorado Schools Mind Summer Camp 2019. Explore computer science for girls and boys entering grade 6 to 9th grade. This camp is developed and facilitated by my students who are passionate about their subjects and studies. Counseling has details.
The Department of Bioengineering program. Biological learning, works in students, Denver exercise. Biosciences, plastic, Johnson Company,
Final care packages. Don't miss out. Make sure a final care package is in order for you. It can still be ordered until Friday, April 19th. Purchase on the Just Code Deals website or on the package sponsor. The cost is $50 for the spring semester. Don't miss out on this opportunity to support school partners. Today during business hours, the Intel meeting
What? We'll go over 99 questions tomorrow. I'll put it to you online tonight so you can check the order. But,
So is 99 with stuff?
number 6, I scratched out to replace with just do 6 from the book.
seniors, this is you clean up
And
my
scratch
Make
20.
sure your transcript fees, fees have been paid, and other activities. Grab a montage board and instructions for after prom. Turn in a senior
If you'll be online, check your work tonight for 99.
reports you have received from all universities by April 19th.
Actually, I'm trying to put a key for 100 on also, but I don't promise you. Okay.